So, take two.
So, take two, yeah. That will go through the process. So what we do, once we're loading up the program, then we'll calibrate the position on the board.
Okay, so that's the calibration point it's just gone to.
Yeah, so there's 3 points on the board that we calibrate against. And sometimes it does just run out slightly of calibration. So we're just checking the 3 corners. That looks alright. That one needs to go that way a smidge. That looks okay.
Okay, you happy with the calibration?
Yeah, okay, so this time we'll go for a run.
Right.
Hopefully we'll get a bit further.
Okay. Oh, it looks like it's got the hang of it this time. As close as I can without it hitting me. It beats putting them on by hand, doesn't it, guys? Hey. So if you go out and get a job in this, is exactly the sort of machine you'll use, because you don't want to do this by hand.
Yeah, so there you go. So it's placed all of those capacitors.
Yeah.
So that you've put solder paste on over the top, and it's gone onto the everywhere apart from where the resist is.
That's correct, yeah.
So the next stage would be to take those boards off there and put those into
Put them in the oven.
the oven over here.
Yeah, to reflow. Well, probably what we'll do is we'll just do a visual check just to make sure that everything's aligned reasonably well, which it is. When it goes into the oven, when the solder melts, the surface tension of the solder will tend to pull some of the components straighter. So we'll put that in here.
I think you'll agree this beats doing it by hand like you guys had to there.
Goes in there, and then we will.
So what temperature are you flowing at?
What we're going to do is we're going to run it on low temperature. So that's started now. So the solder paste we've used is a low temperature solder paste, which melts at around 160.
Oh, that is a low temperature,
degrees
160.
Celsius. Yeah. So the reason we've done that is because on these audio amplifier boards they've got tantalum capacitors, and those particular components don't like heat. So I found if we run it at a regular temperature solder paste, that temperature is about 240, 250 degrees, and that's too hot for the tantalum capacitors, and they change colour. In fact, I can show you a board where we did it at that higher temperature. So you can see, so the board on the right is with the low temperature solder paste, and the board on the left is with regular temperature, and you can see the tantalum capacitor there in particular has changed colour.
Yeah, it's not happy, is it?
Okay.
I guess it would probably still work, but it would increase its failure time.
It probably still work, but it will probably now be a bit more leaky than it should be, so it won't hold its charge as well.
One question I have is like how like the coordinates are set in here. I mean, like we manually set the coordinates, or like
You've got a
we
start point.
On this program, I've manually programmed in all the coordinates.
Okay.
Once you've done it for one board, then that's fine. You can do a whole sheet of 24 or more using that one program.
Sure.
The other way of doing it is in your printed circuit designer software. You export the component coordinates from that program and import them into the machine, which saves you having to manually program it.
So it's right now taking 00 is like 1 to this corner of this board.
Yeah, 00 is the bottom left corner of the board, and then coordinates X and Y are from that.
Okay, then that works. Yeah. I thought like we always like manually do this. If it's like portable from the like the software, it's really easy to
Yeah,
do.
I mean, once the program's in, that's straightforward. You just put the board in, load the program, calibrate the corner position,
Yeah.
and run the program.
You upload the Gerber file or ANSI drill?
No, there is like one file that you could get for the coordinates, like just for the coordinates.
It's actually an Excel CSV
CSV file. Yeah.
file. You
Like
can
there is
export.
another option over there. Not just the Gerber file. There are different options, right? In software,
Yeah.
so we could use one of that.
And how do the components get soldered on it?
Well, that's what we're doing here. So you will use the flow oven.
We should be like programming in here itself, right? Once feeding the thing, then we should be like saying this line have C7, this line have C2. That we have to do it over
Yeah,
again.
that's correct. So what you can do is you can see loads of bays on
Yeah.
this machine, so you can put all the components you want in there. You don't have to use all the reels for one particular type of board. You just tell it what reel you want to use and what component that is associated with.
Oh, sure.
And now you see why the footprint is so important.
Yeah, I know. And now I get it. Like, okay, this is how it is.
That's right. Yeah, the footprint on the board is vital that it matches the actual physical component size. Otherwise, when it comes to reflow, then it's not
Yeah,
going
it won't fit. Yes.
to won't work properly.
It's good, isn't it?
Yes.
Where do you put the